page 301. They tell us what to do when we have a change of variables necessary to find an antiderivative, but it's a definite integral. And what it amounts to is this. Whenever you change your integrand to be in terms of u, you have to change your limits of integration to be in terms of u. Okay? Because the a is an x-coordinate. The b is an x-coordinate. So if we change all of this to u, having an x-coordinate as your limits of integration doesn't make sense anymore. So you change the lower limit of integration to be whatever u equals at x equals a. You change your upper limit of integration to be whatever u equals when x equals b. So if you change the limits, or if you change the integrand, you must change the limits of integration. Here's what I'm talking about. Number 75 on page 305, we have a definite integral, and we're supposed to evaluate the definite integral. So for a moment, let's ignore the definite part of this integral and do what we've been doing. If I'm going to change the variables here, what do you think u ought to equal? Yeah, I'm thinking 2x plus 1 because that's an expression with an exponent on it. So let u equal 2x plus 1. All right, if u equals 2x plus 1, what does du equal? 2 dx. All right, now let's stop and think for a minute. All of that's going to be replaced with a u, or 1 over square root of u, I mean. So that's going to be 1 over square root of u, and then the dx needs to be replaced with something. Well, not a 2 though, right? Don't need a 2. So I'll multiply both sides by 1/2, and I get 1/2 du equals dx. And let's see if we can rewrite our integral now. So ignoring the limits of integration, 1 over, and instead of the square root of 2x plus 1, that's the square root of u. And then instead of dx, that'll be 1/2 du. Now we got to pay attention, so we can make the substitution. Now we got to pay attention to our limits of integration. Okay, got lower limit of integration. Well, actually, I kind of work these backwards. So pretend you don't see that. That lower limit of integration of 0. Let's change it so that it's in terms of u. So right there, where u equals 2x plus 1. If I replace the x with 0, then u was, so whenever x equals 0, u equals 1, doesn't it? So that lower limit of integration is now 1. And if x equals 4, then what does u equal? 9. So the upper limit of integration is now 9. And now everything's in terms of u, including our limits of integration. You follow me on that? It's not difficult to do usually. You just got to remember to do it. So we have 1/2 times the integral from 1 to 9 of 1 over the square root of u d. And we're going to use the fundamental theorem of calculus to figure this out. That 1 over the square root of u is the same thing as u to the negative 1/2. You may not need to write that step in. You definitely need to think that step. Then we add 1 to the exponent. So now I'm ready to take the antiderivative. So we add 1 to the exponent. What's the new exponent? 1/2. Then we divide the coefficient by 1/2, which is the same thing as multiplying it by 2. So we have that 1/2 out in front times 2 u to the 1/2. and this is evaluated from 1 to 9. Now notice I didn't put a front part of the bracket on. I can put it there. I don't have to put it around that 2, do I? Because I'm factoring the 2 out. Well, as you probably know, 1/2 times 2 is 1. So all I got to do now is evaluate u to the 1/2. So we're at this stage, right? We're at the antiderivative evaluated from A to B. So it's the antiderivative evaluated for B minus the antiderivative evaluated for A. So it's 9 to the 1/2 minus 1 to the 1/2. Now, to the 1/2 means square root. So that's the square root of 9 minus the square root of 1. So it's the square root of 9 minus 1. It's 3 minus 1. And that's 2. Any questions? Right there. Think that's what you're going to be thinking. If x equals 4, then what does u equal? If x equals 0, then what does u equal? Okay? Number 98. On 98, the directions say to use a graphing utility to evaluate the integral. Graph the region whose area is given by the definite integral. So they don't even want us to play around with doing it by hand. You know, it's not the old do this and then check it with your calculator directions. It's use your calculator. So we've got the integral from 0 to pi over 2 of the sine of 2x dx. Let's get out our calculator. And let's see what we can do with it. All right, so let's let y, let's see, I need to switch to radians. I'm in degree. So make sure you're in radians. And we have y equals the sine of 2x let's graph that thing. So there's the graph of y equals the sine of 2x. Our lower limit of, so then we do second calc. I choose the integral, which is number 7 for me. Our lower limit of integration is 0. Our upper limit of integration is pi divided by 2. And there we go. One of the things you're required to be able to do on the AP test is to find a definite integral on your calculator. And that's how you do it. Any questions? All right, now, we've already talked about even and odd before. If a function is even, and the definition of even is that f of negative x is the same thing as f of x, that's symmetric with respect to the y-axis. And if it is even, then to integrate it, since there's the exact same region to the left side of the y-axis as there is to the right side of the y-axis, instead of finding the definite integral from negative a to a, we can find the integral from 0 to a and multiply it by 2. An odd function is one that's symmetric to the origin. Its definition is that f of negative x is the same thing as negative f of x. And if we need to integrate that, if it's the integral of an odd function from negative a to a, you're going to get 0 because there's going to be just as much above the x-axis as there is below the x-axis, and the signed areas then are going to add together to give you 0 because those signed areas will be opposites. So we've done that before. The book points it out in this section. So there you go. All right. That's that. Let's do number 104. It says evaluate the integral using the properties of even and odd functions as an a. So we have the integral from negative pi over 2 to pi over 2 of the sine of x times the cosine of x dx. All right. So another thing that we're required to be able to do on the AP test is to graph a function. So let's graph the sine of x, cosine of x, and concentrate right there around the origin. Is this an even function, an odd function, or neither? It's an odd function. So the integral from negative pi over 2 to pi over 2 is going to equal 0. So once we've recognized that it's an odd function, we don't really have anything else to do other than to say that the integral is 0 because it's an odd function. Now, if it were me and I had my calculator handy and this was a question on the test, I'd probably go ahead and evaluate it anyway just to be sure. All right, so if I do that, if I do second calc, and I choose the integral, the lower limit is negative, no, not e, pi over 2. The upper limit is pi over 2. Then we get 0, just like we knew we would. Okay? Questions? And there's your assignment. On page 305, do 71 through 106.